Hi friends, in our previous video we had discussed about the non-ideal solutions. What are non-ideal solutions? They does not follow Raoult's law under all concentrations. Yes, and also we had observed the variation in the graph there. Raoult's law will be generally given as XA is equal to 1 and PA naught, whereas XB is equal to 0. XA here is equal to 0, means it becomes 0. XB means the solvent that is more volatile, its vapor pressure will be more. So this is what we know about the Raoult's law. But now we had also learned about the positive deviation from Raoult's law. Positive deviation from the Raoult's law. How is this positive deviation from Raoult's law given? It is given with showing that the total vapor pressure will be increasing. The total vapor pressure will be increasing. We are studying about negative deviation from Raoult's law. Let us compare some examples and take up the point here. When I use aniline, what is the formula of aniline? C6H5NH2. C6H5NH2. This NH2 I am writing in this method. And we have phenol. What is this compound called as the aniline? We are taking another compound that is called as the phenol. Hydrogen, OH and the benzene ring, that's what we call as the phenol. When we are studying, this is the reactant A and this is the reactant B. If you study about only the forces of attraction between A and A, if you study only the force of attraction between A and A, means when you are taking a mixture having only aniline molecules, they will have some forces of attraction. If you take only phenol, they will have some forces of attraction. But now, what is our study? This is called as the BB and this is called as the AA type of reactants. But what we are doing? We are going to combine this A and B together. We are going to combine aniline and phenol. These aniline and phenol, they will have a strong hydrogen bonding. They will have a strong hydrogen bonding from the oxygen of the phenol to the hydrogen of the aniline. Means when we are going to study here the attraction between A and B, the hydrogen bonding or molecular attraction. The attraction between A, B is more. Attraction between A, B is more. When compared with A or B. When you compare with the individual molecules, this AB molecule is having more forces of attraction. When they are having more forces of attraction, these liquids cannot change into gaseous state. Previously we have discussed the forces of attraction are decreasing. But now what is happening for the force of attraction? The forces of attraction. If you see the molecules that are going into vapor phase, the surface molecules must go into the vapor phase. When the forces of attraction between the molecules are increasing, they cannot go into the vapor phase. Means the vapor pressure of the solution or the mixture is decreasing. Vapor pressure of the solution or the mixture is decreasing. When there is a decrease in the vapor pressure, generally we have represented as a Raoult's law. This is positive deviation from Raoult's law we have learned in the previous class. Now how shall we give the graph for this one? Shall we write like This is used to be the Raoult's law. XA is equal to 1, XB is equal to 0, and here there used to be some vapor pressure. And nowadays XA is equal to 0, XB is equal to 1. Means mole fraction of XB is increasing. And here we have the partial pressure. We got the graph like PB naught that we had learned. This is the graph from Raoult's law we have studied. But when the forces of attraction are increasing, the total vapor pressure will decrease. The total vapor pressure will decrease. When the forces of attraction between the reactant molecules are increasing, the number of molecules that are changing into the gaseous phase decreases, which decreases the total vapor pressure. Now, shall we get our graph like the total vapor pressure is decreasing. There is a decrease in the vapor pressure of the reactants. This is one of the less volatile, and this is another highly volatile dimension. Means those together AB force of attraction are increasing, the total vapor pressure is decreasing. So these are the three main graphs we must study. Whenever the forces of attraction are increasing, this kind of deviation we call it as the negative deviation from Raoult's law. What do we call it as the negative deviation from Raoult's law? So just recall children, positive deviation means forces of attraction between the molecules decreases. So number of gaseous molecules in the vapor phase will be decreasing. But negative deviation means the forces of attraction will be increasing between the molecules and the number of molecules in the vapor phase decreases. So total vapor pressure decreases. So these are the two main cases. It's not only observed in the case of KNR and NA. This is also observed in the case of CHCl, Cl. What do we call this one as? Chloroform. I am separating this one here. We are calling this one as the chloroform. When you add a mixture of chloroform with acetone, and acetone, they will also exhibit hydrogen bonding. Means the hydrogen bonding will be started now between the molecules of chloroform and acetone, which is not present when they are in their individual form. When this hydrogen bond is increasing, force of attraction is increasing, obviously the number of gaseous molecules that are going into vapor phase decreases. So these are the main examples under negative deviation from Raoult's law. So we have discussed these solutions that show negative deviation from Raoult's law or the positive deviation from Raoult's law. They are together called as the ideal solution. Non-ideal solutions. They are called as the non-ideal solutions. So let's take up the next point here. Let us study the characteristics here, general characteristics of ideal and non-ideal solutions. Because we got explanation regarding the general characteristics of ideal solutions, but we don't know the general characteristics of non-ideal solutions. There are 4 points to be studied under. Here we are going to get this one as a tabulated data. So it will make our work very simple. Now let us see Raoult's law. Raoult's law. First general characteristic, Raoult's law. Does ideal solutions follow Raoult's law? Yes, ideal solutions follow Raoult's law. Ideal solutions will follow the Raoult's law. But non-ideal solutions does not follow Raoult's law. Does not follow Raoult's law. And the second thing, regarding volume of the mixture. Volume of the mixture. Mixture is the solution. In the case of ideal solutions, there is no change in volume. There is no change in volume. When there is no change in volume of the mixture, we can say it is equal to 0. It is equal to 0. Why there is no change in volume? Because when we study the forces of attraction between A and B, and now B and B are similar to the forces of attraction between A and B. Means the forces of attraction of products are equal to the forces of attraction that are present between the individual reactants. They have the same kind of forces of attraction, so there is no increase in volume or there is no decrease in volume. But in the case of non-ideal solutions, we have observed two types. One is called as a positive deviation. Our task is to study about gaseous state of matter. Yes or no? Because we are discussing about pressure term, partial pressure term. In the case of non-ideal gases, non-ideal solutions, we have a positive deviation. In that, what happened for the gaseous molecule forces of attraction? Forces of attraction were decreasing. Means number of molecules changing into gases are increasing. Means the volume of the gases are increasing. Volume of the gases are increasing. Means they are not having the same volume as the reactant. So there is a change in volume. There is a change in volume of the mixture. We shall discuss again about ideal. In the non-ideal there are two kinds, positive and negative. But altogether we are bringing for the non-ideal solution, there is a change in volume. It is not equal to 0, just like the ideal solution. Now we are going to bring up another term that is called change in enthalpy. Change in enthalpy. That is heat content. That is the heat content. Here, in case of ideal solutions, heat is not absorbed or heat is not evolved. Heat is not absorbed or heat is not evolved. So there is no change in enthalpy in case of ideal solutions. But in case of non-ideal solutions, there will be a difference in the heat. Means when the forces of attraction are breaking down, we need to just supply little amount of heat to break down the forces. Means that will be what we call, it's an endothermic reaction. Yes or no? If the forces of attraction are increasing between themselves without supplying the heat, then we can say there is an endothermic reaction. In the ideal, non-ideal solutions, there will be a difference in the heat. So what we call, for them, the heat of mixture is not the same of the reactants. The fourth one is at last forces of attraction. Forces of attraction. Forces of attraction means the products formed, that is AB, will have same forces of attraction like the AA or BB. AA molecule or BB molecule. But the A and B that is formed in case of non-ideal solution, they will not have same forces of attraction. Will not have same forces of attraction. They may be increasing in attractions or they may be decreasing in the attractions. So these are the general characteristic difference between an ideal solution and non-ideal solution. And now we will study what the general characteristics of the positive deviated and also negative deviated non-ideal solutions. So let us see here, children. Now the general characteristics of some positively deviated and negatively deviated non-ideal solutions. So now we can conclude them without having any doubt here. The first thing is the property. The property is, we can say here, vapor pressure. First property I want to make as the vapor pressure. Which is having more vapor pressure, positive deviated or negative deviated? Positive deviated solutions are having more vapor pressure. Why do they have more vapor pressure? Because their forces of attraction has been decreased between A and B. So I want to bring in detail like forces of attraction. Forces of attraction. So between the products and reactants, what are these A and B? Products, we can say, between A and B. Forces of attraction are less. Forces of attraction are less. Forces are less than reactants of AA or BB. AA or BB. But when we compare now with negative deviated non-ideal solutions, how about the vapor pressure? In the case of negative deviated non-ideal solutions, how about the forces of attraction? The forces of attraction means AB, that is the products, have more forces of attraction than AA or BB. That results the negative deviated from Rolle's law. Here, when the number of particles that are going to gaseous phase decreases, obviously what happens for vapor pressure? The vapor pressure becomes less in the case of negatively deviated non-ideal solutions. And now, in order to break the bond, like the bond formed between two ethanol molecules, we said we are placing some stone. At time, we need to supply some amount of heat. So, the third property, once you study heat, these may be like endothermic reactions. So, the enthalpy for endothermic reactions will be positive. But in the case of negatively deviated, they are forming more force of attraction between them, and themselves they are releasing the heat to the surroundings. So that type of systems, what do we call? We call them as the exothermic reactions. For the exothermic reactions, the enthalpy will be negative. Means the heat content. Then we use the word heat content. The heat. And at last about the volume. Here, volume stands for the gaseous products. In which case, the number of gaseous molecules are increasing. Positive deviation or negative deviation? Positive deviation. The number of gaseous products are increasing. Means the volume of the mixture increases. Means it is becoming a positive value. The volume of the gaseous products are increasing. Here in this case, in which case? In the case of negative deviation, the volume of the mixture is decreasing. Decreasing means gaseous products. The volume in the gaseous products is decreasing. They have a negative deviation. So these are some of the general characteristics, children. Now we will take up the next important topic, that whenever we had combined two liquids, like you had combined water with another component that is called ethanol. What is the boiling point of water? 100 degrees Celsius. What is the boiling point of ethanol? 78.5 degrees Celsius. Now, when we combine these two, which two? Water and ethanol. They will not boil at different temperatures. They will boil at the same temperature. Because their composition in the liquid phase and the gaseous phase will be the same. And such type of solutions we call them as the azeotropic mixtures. What do we call them as the azeotropic mixtures? And that point we are going to study now. You can note these points if you want. Just have a snapshot. I will go on to the next one soon. I will on this one.